Okay, we're going to be using two things. One is the basic set of trig identities, which I'll make you write down again, and also the difference of squares. Remember that 1 minus x squared factors into 1 minus x times 1 plus x, and so forth. We're going to be doing a lot of that because if you look at the trig identity, a lot of them can be rewritten as subtractions of squares. Now, you may have noticed we use x, we use theta, we sometimes use t, we use other things. Sine squared plus cosine squared is 1. If you divide everything by cosine squared, you get tan squared plus 1 is secant squared. And if you divide everything by sine squared instead, you have 1 plus cotangent squared is cosecant squared. You will need to know these, yes. Those three are very important, very useful. So notice, for instance, if you have sine squared plus cosine squared is 1, then if you move sine squared to the other side, cosine squared is 1 minus sine squared, and so forth. Cotangent squared, moving the 1 to the other side on the third identity, you have cotangent squared is cosecant squared minus 1, which is a difference of squares. Sorry, I keep reading thetas instead of x's instead of thetas. Okay, I'll write a little note. Remember that a difference of squares factors. Also notice that sine and cosecant squared can cancel a bit, since cosecant is 1 over sine. You'll cancel out a sine, and it leaves one of the cosecants left. So in the numerator, we now have cosecant minus 1 times cosecant plus 1. To be a little bit careful, if it was a subtraction, you'd have to worry about the order. But with addition, 1 plus cosecant and cosecant plus 1, they are the same. So you can't cancel part of it at a time. You have to cancel out that whole term, cosecant plus 1. And then the other term was cosecant. So we have two bananas minus 1. Yeah. Next one, sine squared is 1 minus cosine squared. So we're doing the same idea. Sine squared is 1 minus cosine squared, and 1 minus cosine squared factors. And then we cancel off, and we're left with a single copy. Next one, the common denominator is multiply. Unfortunately, addition messes things up. So 1 minus sine t and 1 plus sine t, they're just different. You'll have to multiply them together.
I'm messing around with the left side, see if I can turn it into the right-hand side of the equation. That's what verify.
So if I take my first one and multiply it by the other part of the denominator, probably needs parentheses to make things all clear. And then the other one gets the same sort of treatment.
We've got everything over a single common denominator now. So put the tops together.
Now we've got a common denominator, we just stick things together into a single fraction. And then we have 2 on the top, and 1 minus sine squared, because we can refactor it.
Multiply it out.
And 1 minus sine squared is cosine squared. And 1 over cosine squared is secant squared. Okay, next one, I'm going to note that secant and tangent share a common denominator cosine. So I'll write it this way. So I'm going to turn things into sines and cosines and hope for the best. Secant's 1 over cosine, tangent is sine over cosine. And I'm just simplifying the left side, so I'm going to write down a vertical column and try and keep it on the left. I'm going to multiply the top and bottom by cosine u, and then distribute. Notice that cancels, it doesn't multiply the top. So I have cosine squared on the top because it wasn't a fraction, and then 1 plus sine u. Once again, cosine u, cosine squared is 1 minus sine squared. Ooh, it's starting to look good. I'm trying to write it all vertically so that I'm showing that it's simplifying the left-hand side. I'm just trying to simplify the left-hand side into the right-hand side. That's what proving an identity is. You're not trying to go just anywhere. You're trying to get what the other side has. And we're done. Incidentally, with an identity, you can simplify the left side or the right side or both.
Until you get two things that are exactly the same as each other. Two sides.
But you're starting out with something that you're not sure is an equal sign until you've actually proved it.
Okay, one little thing that I would like to mention, that sine squared is 1 minus cosine squared, but sine is not suddenly 1 minus cosine. I can't even write that even with a single not equal sign. It's horrible to me. Don't do it unless it's squared. So be careful. It has to be Pythagorean. It doesn't work if it's just sine and cosine. It has to be squared. Ditto with tangent and cotangent and secant and stuff.